All right, so today, guys, we're going to start talking about acids and bases. And our first model we have here is a list of Arrhenius acids and bases. Svante Arrhenius, he got the Nobel Prize in chemistry in 1903 doing this work. So you see this, there's a list of acids and bases. And so take a look at that table and pause the video and see if you can think, what are three properties that you notice that all Arrhenius acids have in common? Okay, so hopefully you pause the video. Take a look here. What do we notice? We notice that all of these acids are in this top part. So we have acids in this section, right? You can see where it's listed. And then bases are below. And if you take a look at those acids, what is true? Well, every single one of them have sour taste, right? Every single Arrhenius acid will turn litmus paper red. And they all conduct electricity. So now if they're going to conduct electricity, remember that means that there's got to be some type of charged species in when you put it in water. And that's how you know that they will conduct electricity. All right. And we can also take a look, same thing, and look at the bases. So what do we notice about the bases? Well, we know the bases, they're going to make that litmus paper blue. They also conduct electricity, so they must also produce an ion in solution. And bases have a bitter taste. Now, in the lab, we don't ever want you test tasting something to see if it's an acid or a base, but you can tell. That is one of the ways to tell, like for your food, if you are looking at an acid or a base. Okay, so if you take a look here, we have our citrus fruits, like lemons. You're going to be tasting that sour citric acid. There's acetic acid. That's another one that you'll notice that you have probably encountered because that's vinegar. And what we know is if you take a look at the formulas for all of them, notice something here. Notice that for all of the acids, they all, sorry about that. They all, let's try the highlighter. They all have a proton or a hydrogen that they can give up. And if you take a look at the bases, they all have an OH molecule connected to them for this definition. So for the Arrhenius acid, the acid is something that will increase the concentration of protons. So it has something that will give up protons. Okay, so these square brackets mean concentration. And then a base is something that will increase or give up an OH minus. Okay, so all of the acids that in the Arrhenius definition have a proton, that H, that they can break off of their formula. And all of the Arrhenius bases have an OH in their formula as well. Now, there are a couple guys, Johannes Bronsted and Thomson Lowry, they came up with, they took this definition and they're like, yeah, that's pretty good, but it's not, it doesn't cover everything that's a base, right? And so they came up with something that was a little more general. And if you take a look, here is an example of a base. All right, this is ammonia. And it is a base, but notice it doesn't have an OH minus. But what happens when this gets put into water, take a look, when it gets put into water, one of these hydrogens gets pulled off and put onto the NH3. And so it ends up forming this NH4 plus. But look what's left over, an OH minus. So when that NH3 goes into water, it makes more OHs. Right? It didn't give the OH. It just took away a hydrogen from water, and it made, so there it ended up making more OHs. So the Arrhenius, so our Arrhenius definition, an acid, when you put it in water, it's going to increase how much protons, the concentration of protons in the solution. And a base for Arrhenius increases the OH minus. But then Bronsted and Lowry, and this is the definition that you will see and work with the most when if you end up in IB Chem. All right, so you definitely want to have the Bronsted-Lowry idea in hand. The Bronsted-Lowry definition are acids, and we call this now a proton, or it donates a proton donor, okay, donor. And then a base is a proton acceptor, which you can see in our NH3. Notice that this guy here, he's a base. And why is he a base? Because he accepted a proton from water. Okay, so you can recognize a base because maybe it, like NaOH, it donates an OH minus, or it can be a base if it accepts a proton.